Hello and welcome to Mellow Labs. On today's episode, I'm showing you how I made this ESP32 based instant camera that lets you take a photo and then immediately prints it right after this message from my sponsor. JLCPCB. With 19 years of experience and 5 state-of-the-art factories, it's no wonder that over 5.4 million engineers across 180 plus countries rely on their reliable and affordable services. Getting started is easy. Simply upload your Gerber files, get an instant quote, and place your order within minutes. It's just that easy. Whether you're prototyping or producing in volume, JLCPCB offers unbeatable pricing with 1 to 8 layer PCBs starting from just $2. But it's not just affordability. JLCPCB delivers premium quality with lightning turnaround times. Your boards can be ready within as little as 24 hours. All thanks to their fully in-house production process, which ensures quality control at every stage. And right now, there's an exclusive offer where you can get 6-layer PCBs for just $5 with $30 off of your first order. If you're ready to take your electronic projects to the next level, visit JLC PCB. So I wanted a Polaroid camera for a while now, and eventually I built up the courage to have a look at the pricing of Polaroid cameras. And I very quickly decided that I do not want a Polaroid camera because the refills alone cost like £2 a photo, which is way too much per photo. So at that point I decided that I would just make my own. How hard can it be? A quick search reveals that this is not an original idea. Plenty of people have done this before me, but as far as I can tell, these are all based on a Raspberry Pi, which is fine. A Raspberry Pi is a perfectly reasonable single board computer. But do we need that much processing power? All we really want it to do is just capture an image and then send it off to the printer, right? Why can't we just use an ESP32 camera module? I'm sure that has enough processing power to do that, right? But then I can't find anybody who's done it yet, which means I have to do it. As usual, my search for electrical components begins at DF Robot because they send me things for free. And luckily, they've recently released their ESP32 AI camera module, which to me just seems like an ESP32 camera module with some extra goodies just like sprinkled on there. It's got plenty of RAM, plenty of stuff. I'm sure it will work fine. And coincidentally, DF Robot also sells a thermal printer, and it looks pretty much like exactly what I need. It's a thermal printer. I will say the price is quite steep. If I was paying out of my own pocket, I would probably look somewhere else. But since I'm not, I'm just gonna get them to send me this and the camera module, and hopefully I can just like connect the two together and it will work. So I'm gonna order that and cut to when they arrive. What I'm currently doing is internalizing my anger at myself because I did an unboxing of the printer, the camera, and then connecting them together, but I forgot to press the record button. So there's the printer, there's the camera, they're connected together. The printer comes with a USB cable and a roll of sticker paper. It also has like regular printer paper in here too. And how I connected them, I have a little diagram that I can show you. Okay, so this bit's gonna get a little bit tricky, but I need you to just hang in there with me. So first of all, the printer is connected to the ESP. We have on the printer, we have the receive, transmit, and the DIR pin, which we're not actually using, but also the ground pin. And then on the actual ESP32 module, we also have plus, minus, receive, and transmit. So first thing we want to do is we want to connect the ground. This pen is very dry. Fantastic. So we want to connect the ground to the minus pin. This pen is also very dry. And this is where we get to the tricky part. So with UART connection, which is what this is because it uses TX and RX, we need to connect the receive pin from the printer to the transmit pin of the ESP, right? So we need to go like that. And then in the other one, we need to connect the transmit all the way to the receive so that they can communicate together. And we'll deal with the power situation later if this all works. Right, let's try out some code. Okay, so I seem to have found a tiny bit of a discrepancy and I'm not sure what to do with it. So The printer in the photo looks very much like the printer I got, and yes, this is the link from the store page from DF Robot, so this should be the printer that I have. But as you can see, we've got operating voltage from 5 to 9 volts, and this printer says from 9 to 24 volts. We've also, well, the whole bottom actually looks different because we've got one connector for TTL and then just a regular USB, and then we've got a power input. But on my printer, we have USB, RS232, TTL, RS485, and power input. So like there's a lot more ports on this one. Another thing that doesn't sit quite right with me is the fact that in the code example the baud rate is 9600, but if I actually plug this printer in and hold this button down, it prints out like a little diagnostic sheet, and on here it says that the baud rate should be 1152, which is quite a lot higher. So I'm not quite sure what to do with this information. This seems to be a different printer to the one that DF Robot is selling. So I don't know if I was sent the wrong one or they've changed something. As much as I want to just like upload a script and run it to see if this prints anything out, this seems like a different product to the one that I've received. So I'm actually just gonna email DF Robot and ask about it before I do anything silly. I have some good news. I've received an email from DF Robot, and apparently this is the version 2 of their thermal printer, and if you order one from the same link that I did, you will get the version 2, just for some reason it's still listed as version 1. Bit weird, but okay. So the way you actually find the documentation for the printer is it's actually not listed anywhere on here. The way you find the documentation is you go to the wiki and then you look for embedded thermal printer, and then over here you have version 2, which will lead you to this, which is the documentation for the correct printer. So I was actually right to be skeptical about the code snippet. So first of all, we've got the proper bit rate, but also this has like different modes that you have to select. So it has receipt mode, and I assume like label printer mode for printing out labels. I'm gonna copy off this snippet, put it into my Arduino IDE. So I'm actually gonna get rid of a couple things. So they have like special characters here. I'm not particularly interested in those right now. I mostly just want to see if the printer actually prints what I need it to print. And theoretically, that should be it. Oh no, wait, hold on. I need to update the RX-TX. What are they on this module? I need RX to be 44. So let's open up Arduino. RX 44 and TX is 43. I'm gonna compile that and upload it. Okay, so it's uploaded. Oh, I didn't turn the printer on. Duh. 12 volts, plug that in. That's the printer. Now, if I restart this, it should print, I think? It did! But that's... what is this? Oh, okay, so because I restarted it, the first thing that it actually printed out was a bunch of debug information from the Esp32, and then it did actually print the text at the bottom, and then I waited another second and it printed out the text that I was meaning for it to print. So now I should be able to just change the text and have it print it. Oh, sick! Hell yeah! Okay, nice. So now I want to be able to print an image. How do I do that? Okay, so I actually found a pretty good guide from Adafruit about thermal printers, which is funny because all their thermal printers are no longer stocked, so that's interesting. But yeah, there's a whole lot of useful information, and this printer here looks to be the same as the one I have, so hopefully it works. But yeah, this is honestly just a great guide. There's a lot of information on here it walks you through like how to do your first print, how to power it, code and all that. Though you have a library for thermal printers, which I've already installed. So I grabbed the test script from Adafruit's thermal library printer thing, and I've updated the GPIOs and the bit rate. So hopefully this should just spit out a bunch of like test stuff, followed by a QR code bitmap. Okay. Oh, okay. Yeah, it's actually printing it. Nice. We've got a random Chinese character there. I don't think that's supposed to be there. Can we get a bitmap? This is very spread out. Okay, we've got a barcode. That's good. We've got a second barcode. that it? We've got a question mark, question marks. Right. Okay. So we've got what I assume is supposed to be the bitmap, followed by the fruit. Okay, so I found a different printer library on GitHub. I've installed it, I've got the test script, I've updated that. Oh, I need to change this. Now let's give that a go. Oh, okay. Hold on. Okay, we've got something. Okay, so it printed out the same kind of test stuff, but actually with like proper spacing between them. And then it tried printing out the QR code, but something went. Well, something went. I'm gonna try swapping this over to hardware serial and see if that helps. Okay. Right, that's still not great. Right. Oh, hell yes! So I went back and forth with GPT for a bit and vibe coded this script, and all it does is print a bitmap. And yeah, we went back to the Adafruit thermal printer library, and here I can put in the bitmap I want it to print with the size of the image, like width and height, and it prints it. So let me convert an image into a bitmap and put it in here. I found this website called Image to CPP, and you upload an image, you give it like the size of the canvas. I just went 400 by 400. I don't actually know what the size I can print is. It has a bunch of cool options. You can do black background, white background, invert the colors, and do different dithering, which I think is just different ways of interpreting color in grayscale. So yeah, you do that, you get it to give you a plain bitmap, and then you copy that, and then you paste that into the Arduino bitmap, tell it the correct size, and now if we upload it, it should print out my face. Print my face. Hey, that's my face! Fuck yes! That's awesome! Okay, it's inverted, so we have to invert the bitmap, but it printed it. Now we need to focus more on the ESP32 camera side of things. So I think step one is to, I guess, take a photo and then like save the photo. Or do we even need to save it? Can it just go straight to the printer? These are all questions I need to answer. The first thing I'm interested in investigating is, can the camera capture high resolution stills whilst being handheld, or is it all just going to be like ridiculously shaky? The first thing I installed is the ESP32 camera web server thing, which DFRobot has example code for, and I've got it running up here, and I can click get still, which gets me a still frame of what it's looking at, right? And I can change the resolution here, so I can set it to this, which is, I guess, the max resolution because it's at the top, and then I can click get still, and it takes a second. So I'm worried that when it takes that second, it actually like buffers the frame the way normal sensors do. So if I like hold this, I'm not trying to do it still, I'm just trying to get something. That's not the worst. I do feel like the wide angle lens is probably doing a lot of compensation there. So if I give this like a jostle, it's not bad, but I feel like the wide angle lens is doing a lot of like, well, not compensation, but it just makes an image look less shaky than it sometimes is. So what I'm actually going to do is swap out the lens. I know for a fact that I have a regular ESP32 lens somewhere in here. Ah, there it is. Swapping out these lenses is actually like way easier than you expect. All you have to do is just undo that little thing there, and then they've like double side taped it on, but it doesn't hold on that tight. And then all you have to do is just pop the new camera in, and you can get a whole bunch of these from different sites. And now if I just unplug it and plug it back in, we should have an updated image. It's currently failing to connect to Wi-Fi. And plug back in. Sometimes you just gotta blow it for good luck. There it is. So now if I turn this towards me and capture image, we have a slightly different looking image. Sweet. So now, oh, this camera actually has a lower resolution. I didn't know the camera module actually told the ESP what it's capable of. That's interesting. Okay, so this is high resolution still? That's pretty good. That looks better. It's a little soft, but I kind of like it. Yeah, I like that. Ooh, it's not doing very well with motion. So if I do that handheld. Okay, so this is me holding it as still as possible. It's not bad. And if I give this a little shaky shake. You know what? That's not bad. Unless you're trying to make it look bad. If I hold it just like still, that's pretty good. So now I want to write a script that will take an image and save it to the SD card, and I'm hoping that I can actually get that to work with the boot button over here, because it's exposed on GPIO 0, which I guess just means I can use it as a regular button. So I'm hoping I can press the button and save the image to the SD card. So let me play around with that. I gave GPT the working example script, and I basically just asked it, hey, using this, can you give me a script that takes a photo when I press the boot button and saves it to the SD card? And hopefully that's exactly what it did. Let's upload. Okay, SD card initialized, camera initialized, waiting for boot button. I also got it to enumerate the photos so that, you know, starting from 0 it goes up, and hopefully that should be persistent over restarts, because it should check what the last one was taken and then just use that. So if I press boot, pressing boot, saved image, waiting for boot. Okay, cool. Okay, so I've taken 3 images. So now if I restart it, it should pick up where we left off. Yeah, the next frame is 3. So now it should take frame 4. Well, no, it should take 3, but 4 if you don't count 0. Let's now grab the SD card out and have a look at what we got. Okay, it popped up on my other monitor here, but we have images. Yep, that is one of the images of my face. I didn't actually tell GPT to use the highest resolution camera option, so I might have to do that. But we now have a script that takes a photo and saves it to the SD card. So step 2, can we print the image? Okay, again, I just gave GPT the 2 scripts that I know work, the one for taking an image and saving it to the SD card, and printing a bitmap. I told them that I know they work, and I told it the flow that I want it to have, and it spat out a script that supposedly does what I need it to do. So let's find out if it does. So if I press boot, it should do something. That is something. It's very dark. Is that a light issue? If I like hold up a light, would that help? Oh, hold on. Now it's overexposed? What if I try to get my face in it? That's better. So the way it's currently implemented is it takes the image and then converts it to a 1-bit bitmap, which basically just means it converts like every pixel to either be black or white depending on a given threshold, which is why we get a black and white image. So what I want to do now is see if I can implement some kind of dithering algorithm logic kind of thing to actually give it some, you know, details and shading, that kind of stuff, the same way we did on the website we were looking at earlier. So let's do that. Okay, so this time, instead of explicitly telling GPT what I want, I just asked it like, hey, can you find a way to get more detail out of this image? Now, I looked into it. There's a whole bunch of different dithering models that you can use to get more detail out of an image. And it implemented one of them, and then it tried giving me a little bit of a snippet, and then I asked it to print out the whole script, because why should I? So let's try that out. Okay, so it seems to have compiled and uploaded with no problems. So now if I try to take an image, That's pretty good. That's actually better than I expected for the first go. I I have no comment. It just worked. Well, that's not the image I just took. That's the same image as previously. Why is it doing that? That's so weird. Maybe it's like not clearing the image cache before sending it to the printer? Okay, well, there's two problems I have to solve. One is whatever this issue is, and two, it seems to be like fitting the image into the frame, but I think it's cutting bits off either side. So I'm gonna see what I can do about that, and be right back. So it took a lot more time and selfies than I expected it to take, but I'm at a place where I'm happy with what I have. By the way, if you'd like to buy a Mellow Labs work in progress selfie, let me know. I'll consider putting them up for sale. First of all, the problem I had with the printer printing duplicate stuff was actually because of the ESP32 image buffer thing. It like has two buffers that it keeps like refreshing with latest images. But then what my code did, instead of grabbing the latest one, it would just grab whatever's in the buffer, which sometimes was just a duplicate. So I fixed that. So now it does actually work the way I intended it to work. And for the scaling, instead of getting a big image and then scaling it down, because that was giving me some issues with like detailing, because, you know, squishing things down is not always great. So instead, I picked an image size that is the closest to the size that I'm able to print, which is like 380 something dots. So I'll just show you. I'll just show you how it works. So I've got the latest script running, and now if I press boot, it flashes the LED, it takes an image, it saves it, and it converts it to a bitmap, which it then prints. And also it prints the I could not have planned that better. I could not have planned that. So yeah, it just completely lost my trail of thought. Oh, I was actually talking about the fact that it prints the photo number now. I'm also probably gonna have it print something like the date or like Mellow Labs or something, so that when I take this printer out to like conventions and stuff, I can take photos with people, and it'll have like the event name and stuff like that. So I'm happy with this. It works. I also added a function so that if I hold down the boot button for 2 seconds, instead of taking a new photo, it actually prints out the last photo, but this time it's intentional. So in case anybody wants another copy, I can produce one. So I'm actually super happy with where it is right now. It does pretty much exactly what I want it to do. So my next step is to make an enclosure that will hold the camera, hold the printer, and some kind of battery. I've not fully decided on that yet. So let me go figure that out. Okay, so welcome to my design process. I've got all the components that I'm going to use for this project, and yes, I decided on a power source, and yes, it is this 20-volt drill battery. My dad gave this to me like a while ago, and I've not had a project to use this with, but it's kind of like just about the right size for what I need, especially if I like put the printer on here and the camera. So like I played around with different layouts and stuff, and I kind of ended up with like just having the printer and the camera on here like that, because that's kind of what is, I think, easiest. There's like a whole bunch of different ones I've experimented with, but having to put everything in here, which to be fair isn't a lot, but I do need a buck boost converter to step down the 20 volts down to 12 volts. Now yes, the printer can just accept the 20 volts, but I'd rather step it down before it goes into the printer, and then I can just feed that directly into the printer and the ESP, because this one can handle 5 to 12 volts going in. So I'm literally just gonna have battery going into the buck boost converter splitting off into the printer and the ESP. And then I've got a button that I'm actually just gonna like desolder the boot button that's on here, and then solder on 2 wires and connect that to this button so that I can have this button. I'm thinking somewhere at the back here. It's going to be a little bit awkward because I'm going to have to like hold it like that-ish, but I'm hoping the button will go there, that I can like easily press against it. And I'm also going to have an on and off switch, which is just going to go on the other side of the button. So that's kind of where I'm at with this design. It's not the prettiest. This is going to go kind of like at the bottom here-ish. There, and obviously I need to leave myself enough room for like wires and stuff. But hopefully I can make this work. So I'm going to go jump into Fusion and just kind of push and pull a shape into what I need it to look like. Okay, so after a lot of pushing and pulling, here's where I got. So I've got all the individual components. I modeled the printer and the ESP myself, and then these 3 I just got off of GrabCAD. Thank you for the people that post high resolution models of stuff on GrabCAD. My huge respect. So I kind of just modeled a box around them. It's not the prettiest looking thing, but it should just about do the job. So the switch and the button goes there. And now if I just hide the printer for a second, the button is held in by a little bracket, which just kind of screws into the bottom so that I can adjust the pressure on the button so that I can get it, you know, at the right point so that it's not constantly pressed in. This is where the battery contacts come up from. This bit just slots into the battery, and then to actually connect to the battery, I'm using these like spade connectors, and they just kind of fit in here, and they're like the perfect size and length to just fit in. So yeah, one on here, and this should just like slide in and slide out so I can take it out for charging. And then those contacts go into the buck boost converter, which I could screw in with the mount hose, but I think I'm just gonna like hot glue it down and hope that that works. I'm gonna have the switch disconnect directly from the buck boost converter so I don't like do it upstream. The printer itself, the way it fits in here is hopefully pretty snug. The printer actually has like these little wings that kind of pull up and then pull the printer down to whatever surface they're being attached on. So that's why I have those cutouts. I don't think it's going to work quite as well on this side because the PCB layout of this ESP32 camera module is somewhat infuriating. So they put the USB-C port here, and then the SD card slot is here. The two things I'm most likely wanting to access is the USB port and the SD card. Why not just put them alongside each other and then put that connector there? Like, I already have to plug in things here, so I have to have 2 things sticking out of this side. So like, why not just put that there so that I can have 2 things sticking out on this side, have the 2 things I want to most interact with here so that I can just pull the SD card slot. And this SD card slot isn't one of those the ejecty ones, so I can't just press it down in order for it to eject. I have to like fully get my finger in here and try to pull it out with my nail. So I have to leave myself like enough space to get my knuckle in there, which is just infuriating. And the way I kind of got around that problem is just by not giving myself access to the SD card. If I want to take the photos off, I'm going to have to unscrew this whole module from the body. So I don't think I'm actually going to be able to use the wing that's on this side of the printer, because this is where the printer cable comes out of. And unless I like do a real violent turn down here, I don't think I'm going to be able to get that wing out to push against the top of the body there. But hopefully it should work, just, you know, with some sacrifices. So that's where I'm at. I'm gonna go and print these and I guess just start assembling stuff. So I guess I'll see you in the montage. I sent all the parts that needed to be printed to my printer, and then about an hour before they finished printing, I got a start on the electronics. I started off by laying out all of my components in the rough order that they needed to be connected in, and the first part I decided to tackle was the split that splits the power from the buck converter to the ESP and the printer. And I actually just used a little connector that I can connect and disconnect if I need to change it in the future. So I just used that as like a junction to split it off, and then the other side of the connector I just soldered onto the buck converter. And you might actually spot a problem that I didn't notice at the time but will bite me in the butt later. And I clearly didn't have any sense of order when I was doing this, because after doing that split, I decided to tackle the data cable. I actually had a very convenient cable that had the correct connector size to go between the printer and the ESP, but it was like a little bit too long, so I just chopped it in half, cut off however much I didn't need, and then spliced the two back together with some heat shrink tubing to make it all neat and tidy. Then I decided to tackle the power going into the Esp32, and I was originally going to use the terminal block that they have on there to screw the cable down, but with it coming out the side at a weird angle, it just wasted too much space, so I decided to just remove the block and solder the wires directly into the board, and actually, yeah, that worked perfectly. And then because I was already working on the board, I decided to grab my hot air station and remove the boot button. It didn't really come off cleanly, but I didn't rip up any traces, so all is good. So I soldered on two wires, and then through a little connector, I connected the bigger button that will go at the back of the camera. And then I went back to my back boost converter, connected it to my lab bench power supply set to 20 volts and adjusted the output so that it only outputs 12 volts. And I double checked that multiple times so that I wasn't releasing any magic smoke. And then I soldered on some longer wires with a switch in between. These are the wires that are later going to connect to the battery through the little spade connectors. Then I decided that it was time to test whether everything works the way it's supposed to, and that is where I found out that I did a little bit of a mix-up. It turns out that I just decided, intentionally obviously, to test whether the printer and the ESP has reverse polarity protection, and I'm very happy to say that it does. So I swapped the wires on the connector, plugged it back in, and it worked perfectly. And a little bit after that, my enclosure finished printing, and I had to split this body because I didn't want to use that many supports. So I actually split the main body container thing from the battery connector just to save on supports. It still needed a little bit of supports around the button, the switch, and like the main opening where the Esp32 goes. So cleaning that up, I could start putting things together. I started by just gluing the battery holder onto the case with a lot of glue. I realized I probably used too much glue, but better safe than sorry. And when those two dried, I started putting in the electronics. So I put the switch in with the buck boost converter and then poked those extra long wires through the holes that will go to the spade connectors. And then I didn't really put too much thought into how I was actually going to put the spade connectors in the right space. So I actually just ended up like using a ruler, marking it, filling the holes with hot sticky stuff, and then just kind of holding the connector until it dried or cooled down, and then it actually fit the battery perfectly. So not the best way of doing it, but efficient. And then I moved on to the button. The hole needed a little bit of a sanding just because it was a little too snug, but then the button fit in perfectly, and I screwed in that little brace that holds it at the back, and honestly, no complaints, it works perfectly. And then I plugged everything into the Esp32 and screwed it in. I'm not using any heat press inserts, I'm just taking an M3 screw and screwing it directly into the 3D printed holes, and it's not the best way to do it, but honestly it's holding on. I've not had any issues with it. And then the final piece of the puzzle was the printer. I connected the power, the data, and just dropped it into the hole, and honestly it was a very good snug fit. I did have to maneuver the wires out of the way a little bit, but apart from that it was perfect. So I plugged in the battery, turned it on, pressed the button, captured an image, and it worked perfectly. Before you mention it, yes, it does bother me that the DF Robot logo is upside down, but apart from that I actually think it looks pretty good, until you add the battery and it kind of gains a caboose. My flatmate told me that it reminds him of like a medium format camera from like the oldie days, so that's pretty cool. Apart from that, I'm also going to bring this with me to Maker Central, which is in May, which is when I'm publishing this video, so I'm not giving you a lot of time to think about this, but if you want to come and take a selfie with me and then walk away with the selfie, you know, come say hi. I don't have like a space where I'll just be roaming around, so if you see me, just flag me down. But apart from that, I'll leave the code and all the links to all the components and the files to print this, although I don't think you'd actually want to print this, it's very specific to this battery. But yeah, I'll leave all that stuff down below the like and subscribe button, and please do hit them, and if you can, please support me over on Patreon. And yeah, I guess that's kind of it for this episode. Thank you very much for watching, do all the things to appease the algorithm, and I'll see you on the next episode.